Hey guys, this is Manoj here, having around 20 years of industry experience, carrying good knowledge in DevOps, cloud, and multiple other technologies. So, guys, agenda is to make you clear what is a Docker, Docker Compose, Docker Swarm, and hands-on. So, let's start first topic, which is Docker Compose. What is Docker? Okay, and what are the important components of the Docker is there? How Docker Compose will come into the picture, and then we'll end up with Docker Swarm investigations. Okay, so let me start with first why Docker is required. So guys, whenever we work for any environment, whether it's a dev environment or test environment or pre-prod environment, few things are common across. Okay, if it's a dev environment, test environment, pre-prod environment or prod environment, QA environment, pre-prod environment, and prod environment. These are the basically four environments are there, which people usually work on. And what is common across the environments is two layers are common across. One is the installation layer, okay. Another is a configuration layer, which is common across all the environments. For example, let's say if you are installing Tomcat, JBoss, or any other server, that is a common across. That is a common across. So these two environments are common across. I mean, these two layers are common across in any of the environment. I mean, they are meant to be common. Now, whenever you do a deployment, that is something which is dynamic, which is a different from the previous release. So when you go for a deployment, this guy is dynamic for you every time after you do a new release. Okay. So this guy is actually the dynamic component. So whenever guys you move the deployment layer from one environment to another environment, you must be seeing that your code works fine into the lower environment, but it doesn't work fine into the higher environment. What is the reason why our code doesn't work fine into the higher environment? What could be the reason why your code works fine into the lower environment, but why it doesn't work into the higher environment? Due to environment dependencies, due to environment configuration changes. So for example, when these environments were built, let's say you install Java 1.6. Now, sometime higher environment would be managed by different teams. Let's say a team would be downgrading the Java version because of any specific issue. So your higher environment may have a different Java version, which leads to this inconsistency across the environment. Now, what is the solution? Solution is only thing, can we package all the dependencies, okay, in one binary form? For example, let's say I have these four environments are there, let it be. I have these four environments are there, let it be. Now, when I'm working on these environments, okay, so whatever our three components are there, configuration layer, deployment layer, and installation layer, if somehow I will able to package them as a one component, okay, if I will able to package them as a one component, if I'll make them as a package, and when I'm moving them from one environment to another environment, instead of moving as one component, if I'll package it and then move as a complete package from one environment to another environment, okay, so actually I'm moving all the dependencies so that there won't be any differences from one environment to another environment. So guys, do you think if I will move in such way all the package dependencies, I can get rid out of the problem of having environments not simulated to each other? What do you think? This problem can be solved, that our environments are different from lower to higher? Yes, at some extent. I mean, 70-80% this problem can be solved, right guys? I would not say 100%. What do you think guys? Others, can we will be able to solve this problem at some extent, right guys? We'll able to solve this problem at some extent, right? So guys, this packaging the dependencies, we are calling this mechanism as a containers. Okay, we are calling this as a containers. We are calling this as a container. This mechanism, we are calling it as a container. We are calling it as a containers. Okay, and there are multiple containers are there in the market. Can someone name what are the containers are there in the market? Docker is one of the container. Then, so have you heard about RKT? RKT is one of the container. LXC is another container, but most likely people learn the Docker container only. Yeah, so guys, Docker is one of the best known container in the market. Okay, so containers are very much similar to a virtual machine. Okay, in the market, we are using containers as a substitute to the virtual machine. Now, the question comes, what is the difference between a virtual machine and a container? So let's discuss that part. So guys, whenever we develop a virtual machine, when we create a virtual machine, first we should have our hardware should be there. Okay, on top of that, we will have our operating system should be there. Okay, on top of that, we will have our hypervisor would be there. Hypervisor is nothing but this is a software which will help to create virtual machines. Okay, different type of virtual machines are there. Let me color it in the same. Yeah. So guys, as I told, on top, you will have hardware is there. On top of hardware, you will have operating system is there. On top of that, you will have hypervisor is there. So hypervisor is a software which will help to create virtual machines. Okay. So the structure of the virtual machine is you are going to create multiple virtual machines on top of a machine. Okay. So guys, which type of virtualization is this? What kind of virtualization is this? This is called hardware virtualization, right? This is called hardware virtualization. This is called hardware virtualization. Now, if I'll compare this with containers, okay, so you will have hardware is there, you will have operating system is there. Now, instead of having a hypervisor, to create a container, we need a container type of environment. Okay, for that need a software called Docker engine. Okay, we need a software called Docker engine. How do we identify whether it's a hardware virtualization or other? So whenever you create a virtual machine, you are actually virtualizing the compute capacity of a existing operating system. Okay, so that's why it's a hardware virtualization. I mean, you need not to identify anything. This is what is being written in the books, and that is how it is being configured. Okay, so yeah, so if I just compare with virtual machine configuration, you will have a hypervisor is there, and you will have Docker engine is there. Okay, and on top of Docker engine, instead of virtual machines, you will have Docker containers will be there. You will have Docker containers will be there. Okay, so now guys, if you compare virtual machines with the containers, more or less they serve the same purpose, but there are a lot of differences are there between. What are these differences are? Let's say if we have to make some apple to apple comparison. Okay, so let's me pick up a virtual machine. So guys, what do you think, how much time it takes to start a virtual machine? 2 to 3 minutes, right? So on an average it takes 2 to 3 minutes of time. Now guys, how much memory does a virtual machine consumes when it starts? I can configure 50 GB, but whether 50 GB is required or not, right? So around 2 to 3 GB is required to start a virtual machine. Okay, so VM1 requires 2 GB of RAM. Okay, same way if I will come with V2 also required 2 GB of RAM. Okay, startup time is same. Okay, but let's say V1 is requiring 2 GB of RAM to start the OS, but let's say I'm running an application which might require 1 GB of RAM. Okay, same way for V2. V2 require 2 GB of RAM, but the application which is running might take 0.5 GB of RAM. Same way in V3, it might require 2 GB of RAM, but app would be required maybe 1 GB of RAM. So guys, to start an application overall, which is having 2.5 GB of RAM total, I need a VM cost is 6 GB. Okay, so you see what is the overhead is there to start 2.5 GB worth of application. I need 6 GB of RAM, right? I need 6 GB of RAM. So do you think it's a justifiable that I need 6 GB of RAM to start 2.5 GB of applications? Do you think guys it's justifiable, or we have to see some improvements? We have to bring some improvements. Yeah, we definitely need some improvements, right? We need to bring some improvements. Okay, apart from that, our startup time is 2 to 3 minutes. or startup time is 2 to 3 minutes, right? Now, when we do this comparison apple to apple with containers, so you'll be very much surprised to see that containers doesn't take any memory to start. If it takes, it's very, very negligible memory. Okay. C2 is taking very negligible memory. C3 is also taking, guys, you can blink your eyes. Yeah. C3 also taking 2 GB of RAM. Okay. And with that, your overhead will be start container overhead will be 0 GB. So a lot of savings are there. Now, whatever 6 GB we have saved here in the containers, this can be utilized to start more applications. Okay, this can be used to start more application. So isn't it, guys? It's very, very interesting fact, right? Is it a considerable fact like we spin up more number of machines or more number of applications with that memory which is being saved, right? Now, guys, what do you think? What will be the startup time of a container? What would be the startup time of a container? It's guys, it's 1/10 of the second. I mean, 1/10 part of the second. Okay, it's like a single millisecond. Okay, the moment you will do eye blink, a container should be ideally getting started. Okay, the moment you will do eye blink, container should be getting started. Okay, this is how containers are doing great. Okay, so startup time of a container is 1/10 of second, means single millisecond. Okay, the moment you will do eye blink, your container will be getting started. Okay, so guys, we have talked about containers, images, docker files. So this is a confusion all the time, what is meant for what. Okay, so let me clear this confusion. So what is the difference between a class and object? What is the difference between class and object? Object is an instance of a class, right? Can we have multiple instances of the class? To create a class, do we need to have a source code file? As in Java, we need a Java file to have a class file. Do we need to have a source code file to create a class file? Yes, guys, right? We would need it. So, guys, I mean, if you have clarity on this scenario, Docker is also very much similar. So we have a Docker file is there, which is nothing but a source code file. Okay, which is nothing but a source code file. Okay, we write source code in the Go language in the containers. Then you will have images there. Image is very much equivalent to a class. With the image, you can create many containers. So containers are nothing but instance of a class. Okay, they are nothing but instance of a class. So with the Docker file, you are creating an image. With the image, you are creating multiple containers into it. Okay, now on the storage side, so there is a tool is there called Docker Hub, which is a repository given by Docker company, wherein you keep the images. Okay, this is a public repository. You can have your own private repositories also. There are multiple tools are there in the market. For example, Docker Hub, you can purchase the licenses, host in your own premises. Okay, and you can go and host your images in Nexus repository also, JFrog repository also, Azure Docker Artifactory also. Okay, AWS has come with their own repository called AWS Elastic Container Repository. So multiple tools are there which can be your private repositories. Okay, which can be your private repositories. Okay, so these are your private repos. Okay, and this is your public repo. Fine. So guys, in this Docker Hub, you can upload your own images. Shouldn't be a problem. But whatever images which are supplied by Docker company, okay, they keep the source file of that or Docker file of that particular image in GitHub. I mean, when you go to the Docker Hub, you will see there are some automatic references are there. Okay, so Docker files are being placed in GitHub. For example, if I'll go to hub.docker.com. Okay, so this is the Docker Hub repositories there. Let's say if I want to search a Jenkins image, Okay, you can see a Jenkins image is there. Okay, if I click on this, Jenkins image is there. But if I want to see where the source code of the Jenkins image is being placed, I can go, okay, and see here where the Docker file is being placed. So Docker file for the particular version of the Jenkins file, this image is being placed in GitHub. So guys, whenever any image is being launched by a Docker company, they are keeping their source code in the GitHub. Their source code in the GitHub. If you want, you can also upload your image over here, but you need to have your own namespace is there. Okay, namespace as in you have your own prefixes there under which your image will be getting stored. For example, if there is no prefix, means that image is given by Docker company. If there is a prefix Jenkins slash Jenkins, means this is a private image is there. For example, if I'll go to my namespace, okay, my own images are also there. Okay, in short, if I summarize it, we have Docker file is there by which we are creating a image. With the image, you can create multiple containers. Image are usually getting placed into the Docker Hub, which is a public repository. You can keep it in your own private repositories also. Docker Hub, you can host it in your network by purchasing the licenses. Apart from that, Nexus repository, JFrog repository, and then we have some more repositories are there, like AWS repos are there, Azure repos are there, wherein you can keep these images. If there is a public image is there for which Docker company is keeping the Docker file in the GitHub. So another topic which is very important topic about the Docker engine, whenever you install Docker engine your any virtual machine, it ships with two components. Okay, so whenever you install Docker engine, it ships with two component. One is called client and one is called slave. One is called Docker slave or Docker daemon. We call it as a Docker server also. Any command which is being fired by Docker client, okay, will be honored by Docker daemon, okay, and they are the part of the same machine. They are the part of same machine. So if I will find a very nice picture, client server architecture, yeah. So yeah, this is the good diagram to understand this. Okay, so in Docker engine, we have a CLI, which is client is there. You have a Docker daemon is there. In the same machine, if you're firing a command, that command is actually going and talking to the Docker daemon, and Docker daemon will be honoring your command. If you want to create an image, if you want to create a container, if you want to push your image to the Docker hub, if you want to pull your image from the Docker hub, everything is taken care by Docker engine. You must be firing the command in the CLI that's getting honored by Docker daemon. So we will do some hands-on, guys. Okay. So let's install Kubernetes. So there is a single line is there, guys, by which you can install Kubernetes. So yeah, just type these two commands. So guys, I'm installing Docker engine here. So guys, now if I'll type here Docker version, you'll see that my client and server both are installed. This is my client, okay, and this is my server. Both are installed. So now if I'll be firing any command from Docker client, it will be honored by Docker server because daemon is there. So what we'll be doing is from client, if you're firing any command, okay, let's say I'll make a new diagram. From client, if you're firing any command, okay, that will be honored by Docker daemon. For example, let's say you want to pull an image. You're firing a command, I want to pull an image. So you can type a command Docker pull, okay. If you type a command Docker pull, then that image will be brought in from Docker registry or Docker hub. So this guy Docker daemon, he'll be honoring this command and it'll go and bring the image from Docker hub and then it will download it here. Okay. For example, let's say an image has come. Okay. So guys, whenever we work for any of the programming language, a new programming language for learning purpose, which is the program is there which we use? What is the first program for any programming language? So probably we can try it out this scenario. I can pull an image from Docker Hub via Docker daemon. And then in the next command, if I just type this command as a Docker run, this will go and create this as a container. Let's try it out this. So if I'll come this virtual machine, if I type just the command Docker images, you don't see at the moment any image. If I type here Docker PS, you don't see any of the process or any of the container which is running. Now let me type a command Docker pull hello world. So what it will do is guys, it will go and pull the hello world image from Docker Hub. By default in Docker engine, we will have references are there of Docker Hub into it. So when I'll type it here, you can see the image is being downloaded. Okay. If I type here Docker images, hello world image has been downloaded. Now guys, whenever we run hello world program, okay, it just print and exit the program, right? If it's a Java program or a .NET program or PHP program or a Python program, it just print hello world program and then it gets exited, right? So guys, whenever you run this Docker Hub image to be converted into a container, it will print hello world and then container will be exited. So guys, if you want to see if there is a running container is there, you can run the command Docker PS. If you want to see any So if you want, you can push the images. If you want, you can pull the images. So guys, now guys, let's move on to the Docker Compose. Now we have a good foundation is there to understand the concept of Docker Compose. So guys, I'll ask you a few questions. If I have an application is there wherein I have a front end part is there or back end part is there, okay, do you recommend to incorporate back end and front end as a part of same container, or we should have a different containers altogether for them? Guys, I have application wherein I have a front end is there, I have a back end is there. Do I need to have a separate front end or separate back end, or we should have same containers for both the applications, I mean both the modules of application? So ideally guys, always we have to decouple the components of the application so that maintenance will be easy. Always remember guys, the principle of DevOps is reusability. Okay, so always try to decouple your components so that your maintenance should be easy. So if you have application is there which is being divided into multiple components, let's have separate container for separate component. Have you heard about mean stack application? Okay, mean stack application, there is a mean stack is there, we'll discuss that. Okay, so they have divided their all four components as a different modules, and they're calling it as a mean stack. M has a different mean into it, E has a different mean into it, A has a different mean, and N has a different mean. Okay, so what we can do is, if I have application is there which has a front end and a back end is there, what I can do is I can create multiple containers out of that. Okay, so let's say I have a front end container is there. Okay, I have a front end container, I have a back end container is there. So guys, what do you think, when we start the containers, backend should be started first or front end should be started first? Backend should be started first. So guys, if I have a separate containers are there, okay, do we need to operate them together, as in like we should set some dependencies which will make sure that backend should be started first, then front end should be started first? What do you think guys, or we should start them manually one by one? So guys, now we are moving towards the automation. So we should make this process automate, but we should make sure that it has to follow the proper sequence, which is a desired sequence, as in like backend has to be started first and then front end, while stopping front end has to be started first and backend should be stopped secondly. Okay, so first backend has to be started, then front end. Okay, and when we are stopping them, first front end has to be stopped and then backend has to be stopped. Okay, so Docker provides one utility called Docker Compose, okay, which helps to start multiple containers together. And with this Docker Compose utility, you can start, I mean, you can start the containers together, you can stop the containers together, you can remove the containers together, you can remove the entire footprints of the container. Whenever Docker Compose starts, it actually starts in a Docker Compose network. Okay, there is a network which gets created, so you can do multiple things with the single command. Okay, that through a utility called Docker Compose, we will see how to install the Docker Compose. So how it works is, it treats each and every container as a service. Okay, it's a set of application or it's a service. Okay, and you can set the dependencies between multiple services, as in which has to be started first, which has to be stopped first. So for that, you have to write a YAML file called Docker Compose YAML file. Okay, and then in the Docker Compose YAML file, you have to set all the dependencies. So basically it's nothing, this Docker Compose YAML file will be calling the REST APIs through Docker Compose, and which will be making sure the start the containers in a particular order. Again, this is the kind of front end for you. So let me open one of the YAML file. Okay, so you can see here there is a YAML file is there wherein we have mentioned the versions. So version is nothing but it's a telling that what sort of REST APIs we'll be using. And we have two components are there. One is a DB container, one is a WordPress container. So DB container also we are treating it as a service. WordPress container also we are treating it as a service. Now WordPress should be dependent on DB. Okay, so if you start WordPress by chance as a first order, so it will be automatically be picking the DB. Their environmental variables are set, their images are set. Okay, and their volumes to be shared are also set. So let me copy this guy, let me go to my virtual machine. Okay, let me create a folder called Docker Compose. practice. Let me go to Docker Compose practice, and then let me pick up the utility to be installed to get the Docker Compose. So just two lines are there, guys. This is the first line, and this is the second line, which gives access to Docker Compose, admin access, and that's it. And let me create a file called touch docker. You can see here docker-compose.yaml file. Okay, let me go to Docker Compose YAML file. Okay, and let me copy paste this code. Okay, so I'm doing nothing, guys. You can see here. Okay, there is a version is there, there is a services are there. In the service I have two containers are there. One is a DB container, one is a WordPress container. WordPress container is dependent on the DB container. Okay, and I have port forwarding is there, environmental variables are there, multiple things are there. As many containers you have, as many services should be there. All the dependencies should be set. Which images you want to download, it should be very clearly mentioned. Okay, now I've saved this file. Now if I want to start my both the containers together, instead of I will go and start them one by one, I can type the command docker compose up. It will start both the containers, but it will be acquiring my console. You can see here it should start downloading the images, but it should be acquiring my console. Ideally it should not acquire my console, so we should have a different command over there. So let these containers be started, then I'll tell you what is that command. Yeah, so it is actually started, but it is acquired my console. So I'll do Control C. It will be killing my both the containers. Okay, now what I'll do is when I'll fire the command docker compose up, I will start them in the detach mode -d. Okay, so you'll see them, it has started my containers in the detach mode, but it hasn't acquired my console. Okay, now I'll type here docker compose ps. This will tell me status of my containers, like both of my containers are up. And as I told, when you start these docker compose, it actually starts our containers in a particular network. So if I type here docker compose or docker network ls, you'll see that there is a docker compose practice default. This is a network which is being created, which is only used by docker compose. So when you want to remove entire footprint of docker compose, this network also has to be deleted. Okay, so if I type here docker compose stop, you will see that this will be stopping my containers, both the containers it's stopping. And you can see first it's stopping my WordPress container, then it's stopping my DB container. But when we'll start it, it will be in the different sequence. First DB container has to be started, then my front end container has to be started. Now if I want to remove my both the containers, it will ask me, are you okay to remove them? So it's removing my WordPress and DB containers. If I want to start them, okay, it's saying no containers are there to start. So now I have to relaunch my containers. And what was the command to relaunch my containers? Guys, what is the command to launch the containers? Docker compose, then docker compose up -d, right? Okay, so now it's launching my containers. Okay, now guys, if you want to delete entire footprint of the docker compose, then we have a command is there called docker compose down. It will stop your containers, it will remove your containers, it will remove your network as well. Okay, so you can see it's stopping the containers, it is removing the containers, and it has removed the network itself. Okay, which was created because of this docker compose. So guys, Docker Compose utility is there when you want to start multiple containers. For example, mean stack, if you see here, mean stack has four components into it. Okay, your MongoDB, Express, AngularJS, Node.js, four components are there. So we can create one container for all of them, or we can create a separate container for all of them. Mean stack is a very good example if you want to use Docker Compose, because mean stack allows to start multiple containers at the same time with the single command. Okay guys, I'll wrap up the session here only. Thank you guys.